Here are the improper fractions as we talked about. Improper fractions are fractions in which the numerator is larger than the denominator. So 7 over 4, 5 over 2, and actually this one I'm going to change. This one isn't an improper fraction, but now it is. Okay, now it is. That's the improper fractions. 13 over 4. I was copying and pasting something I completely forgot to double check when I was putting it together. And after teaching it the first time, I would have thought that I would have changed it during the first time, but I didn't. Anyway, so here we have improper fractions. So what we're going to do is we're going to convert improper fractions into mixed numbers. Okay. So when we're converting improper fractions into mixed numbers, one thing to keep in mind is the denominator doesn't change. Okay. So the denominator for this one is still 4. But with a mixed number, we're gonna try to place a whole value here in front of this fraction. Right? So that whole value represents how many times does this 4 go into my numerator. So how many times can 4 go into 7? Once. And that's where we put the 1. But now, what we want to do is we want to multiply 4 by 1, and we get 4. How many more numbers are we away from getting to 7? 3 more. And that's represented with our numerator. Okay? So, to go from 4 to 1, we're going to multiply. Then we're going to take from here to here, we're going to add. So, 4 times 1 is 4. 4 plus 3 is 7. Okay. So now, with the next one, denominator, as we said, doesn't change. It's 2. How many times does 2 go into 5? 2 times. So, 2 times 2 is 4. How many more to 5? 1 more. Okay. Last one. 4 here, right, is our denominator. Our denominator doesn't change. So how many times does 4 go into 13? 3 times. So 4 times 3 is 12. How many more to 13? 1 more to 13. So the answer is 3 1/4. Okay. So now, what does this mean, 3 1/4? What does this mean, 3 1/4? 1/4 of a whole. So if we're referring to it as pizzas, we're referring it to 3 full pizzas, and that one piece that's, or the pizza that's left over us just eating, let's say maybe 1 more slice if the pizza's broken down into 4 parts. Okay, that's 3 1/4. Now, what if your improper fraction works out to the following? So let's put in one. 6 over 2. 6 over 2. What are we going to do? What are we going to do?
You just divide the 2. How many times is the 2 going to 6?
Okay.
And nothing.
And then nothing up here?
After you put 3.
So we just put 3. Okay, now this don't do. Right? Because in reality, what's 0 over 2? 0. 0 times 3? 0. But the answer isn't 0. Right? So when we have something like that, just really, in reality, what you can do is, well, let's look at how we simplified fractions before. What number divides evenly in both the top and bottom? What divides evenly? 2. Right? So 6 divided by 2 is? 2 divided by 2 is? So the answer can be written as 3 over 1 or as 3. That doesn't exist. Yeah.
I was going to say something. You could just use 6 divided by 2. That one line means divide.
Exactly. Exactly. We can do that. But remember, we couldn't do that with, let's say, if it was like the 13 over 4. Right? So just be aware that if you do have a number that where the numerator divides evenly with the denominator in an improper fraction as such, just divide them and write it down as a whole. Okay. But there are more than one way to write it down. You can write it down as just 3 or any whole number, right? How do you write it as a fraction? Put it over 1. Right, so if I have a whole number like 3, how do I turn 3 to look like a fraction? Put it over 1. So mixed numbers. So we show a mixed number, a whole number with a fraction. Right? So we're going to convert now this mixed fraction into an improper fraction. So as we said, when we go this way, we multiply and then we add. So what doesn't change from this? The 5, right? Our denominator. So 5 times 1 is plus 2, 7 over 5. Okay, this next one here, our denominator is 9, right? So 9 times 3, 27 plus 5, 32. Can that be simplified any further? Can we divide top and bottom by anything evenly? No. There is a number. What is that number? 1, but we never use 1 because it doesn't change anything, right? So we could say, students will say, well, sir, we can divide it by 1. But 32 divided by 1 is? 9 divided by 1 is? It doesn't change anything, so you just added a step that's pointless. Time consuming.